the data is not only to store but to be processed. 1 zettabyte stands for 10 to the power of 9 terabytes. The programming language that we use may be C, C++, Java, PHP, whatever. Search, what you will get is combination of heterogeneous form of data. Each day, the 500 plus terabytes of data. Hello students, welcome to the session of Cloud Computing and Big Data Analytics. I am Dr. Soumeshri from Department of Computer Science, Vidhyaashram College. Let's start this session with a new unit. Okay, in the last session, I told you about the different concepts of cloud computing, where the cloud computing can be used to perform input, process the data and produce the output using the remote server and a network, isn't it? So this is what about the cloud computing and various concepts of the cloud computing. All right. Now let's get into the next unit, that is all about the big data. The third unit and the fourth unit are all about studying what are the main things or concepts of the big data. Like what are big data, what is big data, types of big data, how to acquire a big data, and what are the applications of the big data and other related concepts mainly related to big data. Even though it seems that the cloud computing and big data are two separate or independent subjects, but the reality is the cloud computing and big data are interrelated with each other. How they are interrelated? Let's check with the study of this third and the fourth unit. All right, let's start the session. The session is all about the introduction to big data. How to introduce you to the big data. All right. The first thing what you need to know is obviously the definition of big data. What does the big data term means? All right. Let's check with the definition. What does the definition of big data suggest you is it is a collection of data. You have collection of data. What kind of data? If every data is collected as such, can you call it as big data? Suppose I am storing a table of odd numbers up to 1000, or the list of table of even numbers up to 5000. Whether it is a big data. Can you consider all these as a big data? No, it cannot be a big data. Data and big data, both terminologies are there. Then what is the use of, or what is the meaning of or purpose of using the term big data? Big is bigger, isn't it? So we know what kind of data is considered as big data. Which category of data comes under the division of big data? It jumps from the category of data to the big data. So it is what we get the normal doubt when you start studying or knowing about the term big data. Let's check with this. Okay. As I said, big data is obviously a collection of data. What kind of data is? The kind of data that is stored as or recognized as a big data must be huge in volume, big data. So we have the term big data. How much it is big? We have to look into it. The general terminology with big data is data that are huge in volume or largest size or big size of data can be considered under the category that is big data. Okay. Along with, already it has a huge volume of data. Along with that, it is increasing or expanding exponentially, not linear. It is increasing exponentially, 2, 2 to the power of 2, 2 to the power of 4, 2 to the power of 6, like this. It is exponentially increasing, the type of data which gets exponential expansion. It is exponentially expanding the data, which is called as the big data along with time. What time you are considering? You can consider with a minute or second or hour or a day or a week or a month. You can take any parameter of the time. With each parameter of the time, you can observe exponential growth in the size of the big data. All right. Along with that, again you can have another definition as it is a data with so large size. It is so big that and is complex that none of traditional data management, we have the RDBMS, DBMS, which can store and process the data. The big data is so much big that the normal or the traditional data management system cannot handle such data. It cannot store it or can process it. It is out of the capacity of traditional management system. In such a case, we need to have a new technology which helps in storing, processing and producing the output with large volume of data. All right. What are the few of the examples that comes under the category big data? Can you give me an example is? So we have certain examples here listed. The first example is, we know about the stock exchange, isn't it? Where the prices of the shares and mutual funds, all those things will be marketed, or business or the stock exchange is going to do all those things. The New York Stock Exchange is the biggest stock exchange in the world, where the stock exchange branch generates about 1 terabyte of new trade data per day. In one day, you will get how much of data? 1 terabytes of data in the server. That is a huge volume, isn't it? We cannot imagine using 1 terabyte. We don't use the gigabyte of data to store the data in one day. It is beyond our imagination, isn't it? So what does the big data example says is, the New York Stock Exchange is communicating or generating around 1 terabyte. It may be more than 1 terabyte or little less than 1 terabyte. They have taken the average of 1 terabyte trade or transaction is recorded per day, which is a big kind of data. What we use is, how much we use? Maybe in megabytes, maybe in maximum, maybe in gigabytes, isn't it? Gigabytes is also not possible to store the data in a single day. But this chunk of data is, when you look at it, how much it is storing? Average of 1 terabyte per day. The next example that you can give in a big data is, we have a statistic which shows 500 plus terabytes. See, this is not that much big. New York Stock Exchange, we have a average of 500 plus terabytes. 500 plus, it may increase, of new data get ingested into the database of social media. Everyone knows about the social media, isn't it? All of you are using the Facebook. All of you are using the Instagram. All of you may have used the Twitter, LinkedIn. We have several social medias. You may be using all those things. What happens here? In a server of a Facebook, the study suggests that around 500 terabytes of data are being ingested or provided to the database of the social media Facebook. Every day, each day, the 500 plus terabytes of data. What are the things it may be doing or it may be storing is, this data is mainly generated in terms of photos. Okay, photos, video uploads, message exchanges, comments, replay, all those things, text, audio, video, all the features needed, supporting data, what you are adding new profiles to the Facebook, extra text, profile text, comments, paragraphs, that is posting something, that is an entire article, or maybe there is no limit that only you can use this much of data, or maybe there is a limit. So that means every day more than 500 terabytes of data is flooding into the database of the Facebook server. So it is another kind of big data. Now you may get how big the data can be with few of these examples. You can take some other examples like election or management related tasks, or in election time you will have terabytes of data pouring into the server of the government or election commission. So we have so much of big data. Along with that, if you have a global shopping site, say Alibaba or Amazon, what it is going to do, it is going to accept the request every day for lakhs of requests. All those requests will be stored and processed in data or processed in the server. Again, it may involve terabytes of data per day, isn't it? Maybe banking transaction if you take. If you have a World Bank, it may get, or the nationalized bank in our India only, it may get 1 terabytes of data through the transactions. Various transactions will be happening in various branches. If you take SBI only, it has more than 500 or 1000 branches around the India. Each branch will give certain gigabytes of data to the server, but accumulated, it may become so many terabytes per day. So that is another example you can take for a big data. Okay. The thing we need to know is how to acquire the big data. How you can get the big data, which comes under the term big data acquisition. Acquisition is acquiring, getting for ourselves. How to get the big data. Okay. So different data processing architectures are there for big data, which has been proposed to address different characteristics of big data. We have different characteristics of the big data that we'll study in the coming sessions. So all these characteristics of the big data is handled by the big data architecture. What does the architecture mainly contains is, it is nothing but storing and processing the data, isn't it? So what the characteristics may have is the volume. How does the volume, which volume you must consider as big data? If a few gigabytes of data is provided to the big data server, you cannot accept it as a big data, isn't it? So what must be the volume of the data which can be considered as big data? Then quality of the data, all those characteristics will be addressed by the data processing architectures. Okay. The data acquisition has been understood as the process of, what is data acquisition in big data is, it is the process of gathering. You will combine or you will collect the data. You can gather the data. You cannot store the data as it is. What you need to do? You have to filter the data. there may be junk data or scrap data which are needed to be discarded before storing the data in the database. Once you acquire the data, gather the data, you have to filter it and clean the data. What we are going to store? If we are storing a provision, what we are going to do is, we'll bring the provision from the shop, we filter it for any dust and any material, unwanted material that may be in the provision. We'll filter that. Again, we clean it before we use it, isn't it? Same principle is applied to the big data. The data acquisition or acquiring the data, big data, consists the process of gathering, filtering and cleaning the data. What must be done here is, before the data is put into the data warehouse. Okay, what is data warehouses? The big size of or the server where the data can be stored. You know about the data warehousing terminology, isn't it? Okay, so it will be cleaned and filtered and cleaned before those acquired data or gathered data are put into the data warehouse. We know about the term data warehouse, isn't it? Warehouse is nothing but storage space, isn't it? So warehouse, data warehouse is computer memory space or memory space where you can store the data and which can be expanded, okay, which is called as the data warehouse, okay. Or any other storage solution. Suppose you are storing it in data warehousing or maybe normally in as data, kind of data in server without any formats. You are storing the, dumping the data as it is. And for that kind of storage solution or data warehousing needs the filtered and cleaned data, because the data is not only to store but to be processed. If you want to process a data, you need to have a proper format of the data, isn't it? How do you get the proper format of the data? Is by filtering as well as cleaning. Cleaning is nothing but sorting it into a proper format, okay. All these things will be done before it is stored in the server, okay. The acquisition of big data is usually governed or controlled by 4 of the V's. V is nothing but the words which draws the basic characteristics of the big data, okay. We have 4 V's, that is, one is volume, the next is velocity, variety and value. These 4 V's will control the data acquisition in the case of big data. All right. Here we have a representation of the process of big data, data acquisition. First thing is, you need to have a structured data. You may be having unstructured. How do we get the acquisition of the data is, you may get structured data, unstructured data, events may be stored, event processing. By storing the event, you are next processing the events or business events or decision making events. Whatever is happening in the system is an event. So you have to process the event. Along with that, sensor networks. If you have sensor nodes distributed over the network, you need to store the data that the sensor node is going to capture, okay. Protocols, different rules and regulations related to big data acquisition, real-time processing of the data, then data streams, what kind of data you are going to store, whether it is text, whether it is video, audio or other kind of miscellaneous type of data, what kind of data stream you are storing. Next is multi-modularity or multi-modality is having different versions of different kinds of data that are stored in a single data warehouse. Okay, this is the data acquisition. Let's check with the types of the big data. How does the categorization of big data is going to happen? All right, in this we have three types. As we can see, the structured, unstructured and the semi-structured category of big data. What is the difference between all these three categories? How does they differ with each other? Let's get to know. All right. The first category of big data is the structured big data. What does the structured big data has? Any data that can be stored, accessed and processed. You can store, access and process in the form of a fixed format. You will be having a fixed format to the data that you are using and processing. That data which has a particular structure format or particular format, fixed format, is called as the structured type of data. Okay, we know about the structured type of data, that is database form of data that we are going to store. Okay, it is a structured form of data. You are going to store the details of a student, details of an employee. These are the few of the examples. They are not big data, but the structure of structured data means we will be having a proper fixed format for storing the data, which is called as the structured type of data. What are the characteristics of the structured data is, over the period of time, the talent in computer science has achieved the success in developing different techniques. So why do we use these different techniques is for working with the structured type of data. It has to work with the structured type of data where the format is well known and we have a fixed format and is familiar to us. We know about the format of the data in advance. If I say store the student details, you know about the particular format that you can store the student details, isn't it? What you start with? You start with the register number, student name, the gender, address, maybe Aadhaar number or the student ID number, the telephone number, mobile number, permanent address, date of birth, blood group. All these things we are going to store in a student detail, general detail. If I say create an employee table or store the employee details, what do? You'll create a table of employee ID, employee name, his address, his gender, designation, the qualification, how much he is drawing, in which department he is working, department. There is a fixed format, isn't it? We have various techniques in the computer science or in information technology which can easily handle the structured format of data. All right. And also deriving the value. Also, you can easily process the data in the structured big data or simply the structured data. But the problem here is nowadays we are getting the issues when size of such a structured data grows to huge extent. So we have big kind of data, like if it is a bank transaction, even you have a structured format for storing the bank data, isn't it? But the amount of data that is coming to the server is increasing enormously. Why? Because the use of information technology or IT or digital devices is increasing day by day, isn't it? Before 10 years, only few of the people were having mobiles and even they didn't do anything with the mobile like banking and other things, shopping or anything, isn't it? So the phone was used only to make the call, messages, for only basic things. But today what has happened? Everything is available in the mobile. Everything you can do before sitting in front of the computer or the laptop. That means the usage of the memory in a server or normal memory location has increased enormously in the recent days, isn't it? So we have the huge extent of data coming towards the data server, which are in the size of zettabytes, more than terabytes, that is zettabytes. So in big data, even in structured data format, we are getting multiple zettabytes. What is the range of zettabytes? 1 zettabyte stands for 10 to the power of 9 terabytes. So then 10 to the power of 9 terabytes form 1 zettabytes. You can assume the size of the data that is coming towards the warehouse. How much data you can get in a certain period of time. Okay. The next thing is to know about the example. This is the example of the structured kind of data. As I said, we have the employee table where you can have a structured format or you can have a fixed format to store the data like employee ID, employee name, gender, department, salary ID. Now you may get extra fields like thumb impression or facial impression or face recognition or iris recognition, but they are fixed, isn't it? The formats will not change. Even if you have 1,000 of employees, 1,000 number of employees, 10,000 number of employees, 1 lakh employees, lakhs of employees, the format remains the same, isn't it? So that is called as the structured form of data or simply structured data. Next comes is the unstructured data. We have another category, unstructured data. Today, most of the data that is coming towards the data warehouse from various connected digital devices, they are of unstructured form of data. Then what is the meaning of unstructured form of data? Any data with unknown form. It is not known in which format we have to store, or the structure is classified as the unstructured data. It doesn't have a proper format or fixed format. The format or the structure is unknown to us. We don't know how to store it, to which category of data it belongs, to which format we have to fit the data into. We don't know about the structure, which is unknown. Okay. In addition to the size, we have the big size or huge volume of data. Along with that, you don't have the structure. It is unstructured. You don't know the format, how you can store it. That poses or that gives you multiple challenges. You will, along with the size of the data, huge volume of the data, the unstructured form gives you the extra challenges that may arise while processing and storing as well as processing, and getting an output from the processed data will also be a challenging task for the person who is handling unstructured format of the data. Okay. The typical example of unstructured data, what you can get is heterogeneous data source containing a combination of the text files, images, videos, like our social media. You cannot fit the data that is coming into the social media in a particular format. You may get the heterogeneous form of data, like you may get text files, you will get the images, you will get the videos, you will get the GIF, you will get the short videos, You will get some other form of emoticons and other things which are not having a particular structure. That is what the challenge is, to store and to process and get an output from this processing. Okay, the organizations have the huge amount of data available with them. Each organization has huge amount of data, but the thing is, they don't know. What they don't know is how to derive or how to process a data, or how to process and get an output from such kind of unstructured data. There is no fixed format how you can derive the data. That is one of the main challenge to the processing or analyst in the servers or analyst in the organization to derive a value or derive an output out of the unstructured format of data. Okay, when compared to unstructured, structured format of data is easier to handle. Okay, the example of unstructured data is the Google search we get. If you get to a search, what you will get is combination of heterogeneous form of data. Here we have the texts. Here I have an image. Here I have so many images. Here I have an URL, numeric text files, numeric, alphanumeric, alphabetic, images, videos, icons. So we have heterogeneous files coming to the data warehouse. What we have to do? We have to process all those data. We cannot say that the data that we have obtained or gathered is not in a particular format. I'm not going to process it. It is not going to work. You have to process the data, whatever you get. Okay, that is the unstructured format of data. The third category is the semi-structured format of data. What is the semi-structured form of data is going to do? What are the tasks? What are the challenges in semi-structured data is, it contains both the forms of the data, semi-structured, where we can see a semi-structure of the data. That means some data will be in a structured format, fixed format, whereas some are not in this, but it is actually not defined with example. We have the structured data but is not having any example. A table definition in example is the table definition in the RDBMS or Relational Database Management System. Okay, it is having a structure, it has a structure, but it is not defined. Structure is not definitely fixed for the data. It may change. The form of data that we are going to store may change. Today I have a structure, tomorrow I may get a new kind of data. The warehouse or the server cannot deny that I cannot store the data, that kind of data, or I cannot process that data. The developers has to develop the algorithm such that, processing algorithm, such that they have to get a value or an output even from the semi-structured or unstructured form of data. Example that you can take for semi-structured data is an XML file. Okay, you know about the XML language, isn't it? Extended markup language, where it has certain structure but is not properly defined. It is not properly defined, but it has a structure. Like you have to use the tags. Some structure is, here we have the example, personal data stored as an XML file. You know about the HTML file. HTML file is also a semi-structured because it has certain structure but is not completely defined. Whereas The programming language that we use, maybe C, C++, Java, PHP, whatever you use, all those are structure. You have a structure from where you have to start, from where you have to end the data, like that. You have to start with the open parenthesis, main function. You have to close the program with the closing parenthesis, flower brackets. You have a structure. HTML is a semi-structured. Why? Because HTML and XML are semi-structured data. It won't define from where you have to start, from where you have to end. You can start from any stage and you can terminate it with any stage. Okay. Here we have the semi-structured. So few of the structure is you have to include a tag within the lesser than and greater than symbol. That is one structure. You have to close the tag with a slash and the name of the tag. And other structure is you need to open a tag and you have to close a tag. This is certain amount of or certain percentage of structure the XML file is having and is not completely defined because we don't know from where we have to start, from where to where we have to stop. How you can format it, isn't it? So if you take a C programming or Java programming, it will say it is case sensitive. Java is case sensitive. You have to use S as capital, system.out.println. You need to use these files to get the output. If you want to print something, you have to use the print format or cout function to output this. These are completely structured, isn't it? But it doesn't have all those things. XML, how to print, how to input the values, how to get the output, how to print a statement. All these things will not be mentioned in the XML file. This kind of file can be termed as the unstructured format of the data. All right. In the next session, I'm going to explain few more characteristics of the big data. All right. Thank you.